Right now, somewhere between us and the edge of the Milky Way, something is moving in our direction. It makes no sound. It emits no light. In fact, it devours light. Scientists call it a rogue black hole, and according to current astrophysics models, thousands of them are drifting silently through our galaxy at this exact moment. We just don't know where they are. But tonight, we're going to find out what happens when one of them finds us. It begins 400 years before impact. And yet, no human alive will ever know it's coming. The rogue black hole, roughly 10 times the mass of our Sun, is invisible. No telescope can see it directly. But something strange starts happening to the outer solar system. Neptune shudders first. Its orbit, precise for 4 billion years, begins to tilt. Astronomers call it an anomaly. They recalculate. They recalculate again. Then Jupiter moves. When the largest planet in our solar system changes course, there is no longer any doubt. Something massive, something dark, is falling toward the Sun. And the Earth is directly in its path. Scientists have 72 hours to confirm what most of them already fear. Within 48 hours, Earth's oceans are the first to respond. Gravity doesn't wait for permission. On the side of Earth facing the black hole, ocean tides begin rising, not in hours, but in minutes. Coastal cities see water climbing 30, 60, 100 feet. The Pacific recedes on the opposite side, a horrifying low tide that exposes miles of ocean floor. This is called tidal force, the same physics that governs our tides from the moon, amplified 10 billion times over. But the water is the least of your problems. The Earth's crust, solid rock billions of years old, begins to crack. Fault lines that haven't moved in millennia suddenly rip open. Yellowstone. The San Andreas. The Pacific Ring of Fire. Every volcano on Earth erupts simultaneously. The sky turns black in daylight. Temperatures plunge. And still, the black hole grows closer. Everything I just described. That's what most people think happens. What actually happens, according to Einstein's theory of general relativity, is far, far stranger. And in some ways, more terrifying. As Earth crosses what physicists call the event horizon, the point of no return, something extraordinary happens to time itself. For an observer watching from a distant star, Earth appears to slow down. The light reflected off our planet stretches. Our blue skies shift to deep red, then infrared, then invisible. To the universe, Earth simply freezes. A ghost image suspended at the edge of eternity. But for anyone standing on Earth's surface in that final second, time feels completely normal. You would feel no single dramatic moment of doom. Instead, you'd notice the stars around you begin to shift, warping into a ring of blinding white light called an Einstein ring. The entire observable universe would compress into a circle above your head. Below you, nothing. Pure darkness. The singularity. Before we reach the singularity, if you're the kind of mind that asks questions like this, that refuses to accept that the universe is ordinary, hit subscribe. New journeys into the impossible every week. Now comes the moment science calls spaghettification. And yes, that is the real term used by astrophysicists at NASA. As Earth crosses the event horizon of a stellar mass black hole, the gravitational pull on the side closest to the singularity becomes astronomically stronger than the pull on the far side. The difference is so extreme that Earth, an entire planet, gets stretched like cosmic taffy. First, the atmosphere is stripped away in seconds, launched into an accretion disk of superheated plasma spinning at near light speed. Then the crust tears apart. The mantle follows. The molten iron core, 5,000 degrees Celsius, spaghettifies into a stream of particles thinner than an atom. In less than 1 second, everything that Earth ever was, every ocean, every mountain, every library, every memory ever made becomes a strand of quantum matter, spinning silently around a point of infinite density. And here is where physics breaks completely. At the center of a black hole lies what we call the singularity. A point of infinite density. Zero volume. A place where every law of physics, every equation written by Newton, Einstein, Hawking returns an error. We do not know what happens there. No signal can escape it. No information can return. It is the one place in the universe that is, by definition, unknowable. But there is one final twist that even Stephen Hawking spent his life trying to solve. Black holes don't live forever. Quantum mechanics predicts that black holes slowly evaporate, releasing what Hawking called Hawking radiation, until, over an incomprehensible span of time, they simply vanish. Which raises a question that has never been answered. When the black hole that swallowed Earth finally disappears, where does Earth go? The universe doesn't mourn. It doesn't pause. Somewhere, 400 light-years away, another star is being born in the same cloud of matter that was once the Pacific Ocean, the Himalayas, and the last sunrise in human history. We were here. We looked up. We asked questions. And maybe, just maybe, in some interpretation of quantum physics and information theory, some echo of that curiosity survives beyond the event horizon. Or maybe the universe simply moves on. That's the terrifying beauty of a cosmos without guardrails. If questions like this keep you up at night, you're exactly where you belong. Subscribe to Imagine IF. New impossible questions, every week. Watch our next video. Imagine if moon disappear from sky.